Hi everyone, and welcome to the final video in this series of videos about exam questions on lattice enthalpy. And having done, if you've watched the previous three videos, you're not going to see anything new in this one. The same types of questions come up. I realise you've probably now switched off, but it is good news for us because it means that the same types of questions come up. If we practice them, we know what we're doing. So the first one, we've got a definition of lattice enthalpy again. So as I said in the previous videos, you absolutely must know this definition. So it's the enthalpy change that accompanies the formation of 1 mole of an ionic lattice from its gaseous ions. So we definitely need to know that that definition is worth 2 marks every time. Okay, so that's hopefully a question that you're expecting. Then we've got a Bourne cycle, and this time they seem to alternate between match up the stages on the diagram to A, B, C, D, E, and fill in the gaps in the diagram. We've kind of got a 50-50 chance of getting either of those questions, it seems. So what needs to go in the gaps here? So here I've got calcium plus, and here I've got calcium 2 plus. So here, this should be the second ionization energy of calcium. So this is where I'm going to go to calcium 2 plus. I'm going to leave the oxygen the same because the oxygen is changing in this process. This is the first electron affinity for oxygen. And then I had 1 electron, but now I've taken another electron away from the calcium, so I should have 2 electrons here. Don't forget the electrons, it's easily done. Right, what's going on here? This is an easy one. This process is the lattice enthalpy. So it's formation, if we look at the definition that we just wrote, right, this is the other reason why the definition is important. Obviously you need it for this question, but it also helps you here. If we know that it's forming a lattice from its gaseous ions, well then here's my lattice, so this must be gaseous ions here. Okay. So this is going to be gaseous calcium 2 plus and gaseous O2 minus. Right, we then have to name the enthalpy changes for these various bits. So step A is this one here, which you can't see. Here's step A. So this is from solid calcium and oxygen gas. So these are the elements in their standard states, making the lattice. So this is the enthalpy change of formation. So this is enthalpy of formation of calcium oxide. Step C, what's going on? Step C is this one. So what's changed here? The calcium has stayed the same. The oxygen has changed. We've gone from half a mole of oxygen molecules to 1 mole of oxygen atoms. So this is the atomization of oxygen. You can put enthalpy of atomization, it doesn't matter. But you do need to put of oxygen here, that matters. It's definitely atomization of oxygen, not atomization of calcium. So that matters. Enthalpy of doesn't really matter. All right, and step G, that is this one. So this is O minus going to O2 minus. So this is the second electron affinity of oxygen. And it does matter. We do need to say second. We can't just say electron affinity. Second is important. Probably don't really need to say of oxygen here because there isn't anything else that's doing electron affinity, but it's a good habit to get into. Okay, then we need to calculate it. So we're going to go back to the same method. They've put the values on here for us, which is nice. We're just making calcium oxide, right? So there's nothing to times by 2, so that's good news. So we're just going to need to do, we're trying to do lattice enthalpy again. Okay, so we've got start here and end here. So we're going to go down there, up that one, and then all the way down this side. So then we're going to put the values in here. So we have got plus 798 Again, we're just going to put these in brackets. We've got minus 141 and plus 1145. I've got plus 590 and plus 249. And then I've got plus 178 and minus 635. Right, then we need to make a decision about what to do with these values. So then we compare the arrows. So the arrows are opposite to each other. So we've taken away that one. Here, they're opposite to each other again. Coming down this side, we've got opposite, 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 opposite 4 times, and then they're the same way round. Okay, so we're going to go opposite, 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 opposite 4 times, and then they're the same way round. Okay. Right, let's calculate it. So we've got minus 798 plus 141 by the time we do minus minus, minus 1145, minus 590, minus 249, minus 178, and minus 635. And we've got a very negative number, which is a good sign. Okay. Remember, lattice enthalpy should always be very negative. Right, finally, we've got one of these questions where actually sort of the last question here is always the same type of question. We've seen it worded in various different ways. This is perhaps the most simple version. Describe the factors that affect lattice enthalpy. All of the other questions have been this question, just dressed up in different ways. We've had the explain why this one has a higher lattice enthalpy than this other one. We've had explain why the bonds are stronger. We've had explain why you can't predict which way round it is. But it basically comes down to this. Okay, it's the question about ionic size or radius and ionic charge. Okay, those are the 2 factors, and we've seen this before. So the factors that affect lattice enthalpy are ionic charge. Okay. The higher the charge on the ion, the greater the attraction for oppositely charged ions. Leading to, and then we need to be careful with how we write this in terms of the value of lattice enthalpy, because they're negative. We've got to be really careful when we're talking about, you know, bigger or smaller, because it's negative numbers. It could be misinterpreted. So we're going to say more exothermic. Okay, then that's clear. You can't misinterpret that. So the greater the attraction between the ions, leading to a more exothermic lattice enthalpy value. And then the second factor is the ionic radius. Okay. The smaller the ionic radius, and I'm just going to copy everything I've written here. Okay, the greater the attraction for oppositely charged ions. And these are 2 separate points, right? We need to say both of these. We need to link this factor to the attraction between the ions, and we then need to link the attraction to the lattice enthalpy value. Okay. The greater the attraction for oppositely charged ions, again, leading to a more exothermic lattice enthalpy.